surface area of a three-dimensional figure is the total area of the faces of the figure. Here we have a triangular prism. We're going to flatten it into a net so that we can see each of our faces more clearly to find their areas. To find our total surface area, we're going to start by finding the area of our bases. In this case, our base is a triangle, so that means we're going to have to solve base times height divided by 2 to find its area. Well, on our prism, I can see the base of my triangle is 8 centimeters. The height of my triangle comes out to be 7 centimeters. So that means to find the area of my base, I need to do 8 times 7 divided by 2. 8 times 7 is 56, so to find the area of one of my bases, we need to do 56 divided by 2. 56 divided by 2 comes out to be 28, so the area of one triangular base is worth 28 square centimeters. Surface area is a two-dimensional measurement, so it's labeled to the second power. This tells me that each of my triangles is worth 28 square centimeters. Rather than finding the area of the other one using that equation again, I can simply multiply 28 times 2 to know that together both of my triangles come out to be a total of 56 square centimeters. We can put that into our equation. Area of the bases is worth 56 square centimeters. Now to that, we need to add the area of our lateral faces. Well, coming back to our net, we can see the way it's drawn out that our lateral faces are 3 rectangles. And with the way they're drawn, we can also see that we can put them together into one large rectangle and find its total area instead of finding 3 individual ones. To find the area of a rectangle, we need to do length times width. Well, if I look at the length of this rectangle, it's made up of each edge that touches our triangular base. So 8 plus 8 plus 8. So the length of our total lateral faces comes out to be 24 centimeters. So we can put that into our equation. Then for our width, we can see our rectangle is 9 centimeters across. Well, that comes from the height of our prism, the distance between the bases. So 24 times 9 is going to give us the total area of our lateral faces. 24 times 9 comes out to be 216 square centimeters. We can then put that into our equation for the total area of our lateral faces. So to find our total surface area, area of the bases, 56 square centimeter, plus area of the lateral faces, 216 square centimeters, means our triangular prism has a total surface area of 272 square centimeters. Now let's see if we can take this pattern and put it together into an equation that we can use for any prism. Well, to find the surface area, the first thing we need to do is find the area of the bases. Well, we know area of the bases can simply be abbreviated with capital B. And we also know that prisms have 2 bases. Once we found the area of one base, we multiplied it times 2. So let's put those 2 things to our equation. Area of the base can be symbolized with 2 times big B. Then we had to find the area of our lateral faces. Well, our lateral faces were rectangles, and we saw we can put them together to make one large rectangle. The length of our rectangle came from the perimeter of the base. So perimeter of the base. And then our width came from the height of our prism. So when we want to put those into our equation, we can use P to stand for perimeter of the base, and we can use H to stand for height of the prism. So instead of length times width, we can put P times H. So if we want to find the surface area for any prism, we can come back to this equation. Surface area is 2 times the area of the base plus the perimeter of the base times the height to give us the total surface area. Let's use our equation to find the total surface area of this regular hexagonal prism. Total surface area starts off with 2 times the area of the base. Well, area of the base, they tell me with big B, is 42 square millimeters. So into our equation, we need to put 2 times the 42. And then to that, we need to add the information for our lateral faces. To find the surface area of our lateral faces, it's perimeter times height. Well, since this is a regular hexagon, we know that all our edges are the same length. We were told that one edge is 4, so I can simply multiply that by the fact that we have 6 edges, and 4 times 6 is going to give me a total perimeter of 24 millimeters. So we can put the 24 into that equation. To that, we need to multiply it by the height of our prism. Height of the prism is also thought of as the distance between the bases, which they tell us is 10 millimeters. So we can put that into our equation. Now we can follow order of operations to find our total surface area. So we start with multiplication. 2 times 42 gives us 84 for the area of the bases. 24 times 10 gives us 240 for the area of the lateral faces. Combine those two and the total surface area for our hexagonal prism comes out to be 324, and since this is labeled in millimeters, so is this to the second power. So 324 square millimeters will be our total surface area for our hexagonal prism.